You might be here because you're tired of Windows tax. Every time you run an AI model on Windows, the OS eats up almost 2 GB of your VRAM. If you have an RTX 3050 or 4050, that's nearly half of your GPU memory gone before you even start. In 2026, privacy for developers is no longer optional. Today, I'm showing you how to take full control of your hardware. We are setting up a professional-grade AI environment on Linux using CUDA 13 and NVIDIA 580 drivers. This isn't just a basic setup. This is an enterprise solution that works on both high-end desktops and hybrid laptops. I will show you how to run local LLMs with CUDA, including DeepSeek R1, Llama 3, and even Llama 4 Scout Community Edition, all on a low-end system. Let's start by preparing the system to run local LLMs on Linux. I will be using Ubuntu 24.04 LTS for this video, and it's one of the best options for AI workloads. Before we begin, make sure your system is fully up to date. Next, we need to clean the system. Most Linux driver issues happen because of mismatched driver versions. If you have installed old NVIDIA drivers, they can conflict with the newer ones. To avoid this, first, you need to remove them by running this command. Now, we are going to install the 2026 AI stack. We are using the NVIDIA 580 repository, which gives the latest microkernel updates for Tensor cores. This ensures better performance and stability for AI workloads. Before continuing, make sure the driver version is compatible with your GPU. Once confirmed, go ahead and run the commands one by one to set up NVIDIA drivers and CUDA Toolkit. Once the installation is complete, you need to add a CUDA to your path in your bash RC file. Without this, your AI tools will behave as if no GPU is available even though your system has one. If you are using a laptop like mine with an AMD Ryzen iGPU or Intel iGPU plus an NVIDIA RTX GPU like 3050 or 4050, you have to do one extra step. By default, Linux may try to run your AI workloads on the iGPU, which is not what we want. To fix this, we will use EnvyControl. Now first, make sure you have installed EnvyControl on your system. Go to this link in the description, download dep package and install it using apt. Don't worry about this warning. Then run this command to switch your system to hybrid mode. This allows your NVIDIA GPU to go into deep sleep when you're just coding but wakes up instantly the moment you launch the LLM. It gives you the perfect balance between battery life and raw performance. After rebooting, you can verify the setup by checking that the OpenGL renderer is handled by iGPU. To make this a true enterprise solution, we don't install AI tools directly on the host. Instead, we use Docker to run Ollama. So first, make sure Docker is installed on your system. If you haven't installed Docker yet, check out my video where I explain to set up the right way. Once Docker is ready, we install the NVIDIA Container Toolkit. This keeps your system clean and stable and lets you run different versions of Python or PyTorch without conflicts. Just go ahead and run these commands. Congratulations, now your GPU is fully virtualized, and that's how exactly production AI servers are managed in the industry. So instead of installing the AI software directly on your Linux operating system, you will run everything inside an isolated GPU-accelerated container. It's cleaner, safer, and far easier to maintain. Now let's set up Ollama using Docker and run DeepSeek R1 and Llama like a professional. Just go ahead and run this command on your system. This command starts Ollama in the background using Docker. It allows Ollama to use your GPU for faster AI processing, store downloaded models so they aren't lost, and opens a local port so other applications can communicate with it. In simple terms, this command runs an AI server on your computer that you can access anytime to run and interact with AI models. Now it's time for the magic. Let's install DeepSeek R1 by running this command. This command opens the running Ollama container and starts the DeepSeek R1 7 billion AI model. This is one of the easiest way to run reasoning models like DeepSeek R1 and Llama 3.2. Because we are on Linux, we can also run larger quantized models. Just look at the speed on my RTX 3050, I'm getting nearly 45 tokens per second. That's because Linux gives the AI model direct low latency access to VRAM. You can also set up a chatbot server using OpenWebUI. This command runs OpenWebUI in the background using Docker, so you can use a web interface to chat with AI models. As you can see, it runs perfectly. Now let's talk about the elephant in the room, Llama 4. Since my system isn't powerful enough to run Llama 4 Scout, which needs at least 80 GB of RAM, even a 4-bit quantized version requires around 65 GB of memory. I only have 28 GB total, 24 GB system RAM, and 4 GB of video memory, so the full model doesn't simply fit on my system. However, I tested a 2-bit quantized and highly compressed community version by setting up virtual RAM. As you can see, it does run, but the entire model is running on the CPU with SSD swap instead of GPU. Now because of that, the performance drops significantly. The token speed is only around roughly 0.5 tokens per second. And that's how you properly run local LLMs with CUDA in 2026. Whether you are working on a personal project or building a full enterprise solution, the biggest advantage here is developer privacy. By using CUDA 13 on Linux, you keep full control over your data and build a high-performance local AI setup that doesn't depend on third-party APIs. This setup isn't just about speed, it's about professional-grade security, privacy, and independence in your development workflow. If this guide helped you get your AI lab running, hit that like button and subscribe to see more content. Thank you so much for watching. This is been KSK Royal. I will see you in the next one.